Section 6.3, vectors in the plane. These are the objectives. You can pause to copy and read. I am moving to the next slide. Vocabulary key concepts, again, same thing. Pause to copy and read. I'm moving on to the next slide. Here we go. Let me read this. Component form of a vector. The component form of a vector with initial point P and terminal point Q is given by this formula. And notice that we're using these they're not parentheses, they look like inequality symbols, but this is the notation that we use to represent component form of a vector. And another thing that I want to highlight, notice that is the terminal point Q1 minus P1, which is the initial point. Terminal minus initial. When you subtract, this is going to be the x component of the vector, and this is going to be the y component of the vector. We're going to call it vector v. And the magnitude of vector v is given by this. Basically the difference of the x components squared, difference of the y components squared. And notice that this looks very similar to what you saw in Algebra 1, which is the distance formula. And this, remember, is equal to this. And then you take the square root of the sum of these two squared. Next slide. Let's apply the formula you just saw. It says find the component form and the magnitude of the vector v. So component form, you take the terminal point minus the initial point, 3 minus -1, 5 minus -1, simplify, this is what you get. This is component form. And then the magnitude is just apply the formula you just saw, the square root of the sum of these two squared. You simplify, you get 2 radical 13. Now, let me explain what this means graphically. So if you were to graph the initial point and the terminal point, it generates this vector. This is your initial point, terminal point. What is component form? If you were to graph this vector in component form, this is what you get. From the origin, you go up 4, to the right 4 and up 6. So notice that when you come up with component form, you're basically generating the same vector, but the initial point is the origin. What is the magnitude? The magnitude is, let me change the color here, is basically the distance of the vector. And if you use the Pythagorean theorem, you should see why this is what we get. So magnitude is technically the distance of the vector. Let's move on to number 2. Same directions, initial point, terminal point. Technically, this is what, if you just go through the formula, this is what you get. Nothing too complicated. To compute the magnitude, you're going to be working with fractions, but it should be no problem. And this is what you get for the magnitude. 3 radical 89. And 801, just so you know, is 9 times 89. And that's how we get this answer over here, or the numerator of the answer. Next slide. It says use the figure to sketch the graph of the specified vector. So I give you this information. This is vector u, this is vector v. So I want you to compute 3u. So this is what you're going to do. I am going to write 1u followed by another u, but the new the initial point of the new u that I'm going to write down is going to be the terminal point of the first u. So this is what you get. And I repeat this again. So this is what I have u, which is 3u, which is what I wanted to sketch. 4. So now I need to compute u minus v. So here's your u, here's v, but I don't want v, I want minus v. This is what you get. This is your u, this is your minus v, and then I'm going to do the following. I am going to use what we call the parallelogram law. Parallelogram law. All I do is I take this vector and I place the initial point on this terminal point, and this is what I get. In the same manner, I take this vector and I place the initial point on this terminal point, and this is what I get. At this point, notice that I have a parallelogram, and u minus v is the following vector. So by connecting these two vertices, and this is your answer. And this is what we call the resultant, vocabulary term that you saw earlier. Next slide. Definition of a vector addition and scalar multiplication. Let me read this to you. It says, let u be this vector, v be this vector, and let k be the scalar. Then the sum of u and v is the following. You take the x value of the vectors, you add them, and you take the y value of the vectors and you add them. Scalar multiplication is just k times vector u is whatever the scalar is. This is what we call a constant as well. So you take the constant and you multiply it times the x component of the vector and the y component of the vector, and this is what you get. Next slide. It says find u plus v for letter A. For letter B is u minus v, C 2u minus 3v, and D u plus 4u. And they give you vector u and v right here. So let's do u plus v. So this is my vector u, this is my vector v. I need to take the sum. I apply the formula you saw on the earlier slide. I add the x components, I add the y components, I simplify. This is what you get, 1, 3. B, u minus v. I'm going to take the u vector, subtract the v vector. So then I have to do a little bit of distribution here. This is where you apply the scalar. So you treat this as a -1. -1 multiplied times this gives you positive 4. -1 times 0 is just 0. But this is what you get. You add the x components of the vector. You add the y components of the vectors. Simplify. This is your final answer. For letter C, again, now you have 2 times u minus 3 times v. At this point, you distribute the 2, distribute the -3, and then you add the x components, you add the y components, and this is what you get. At this point, simplify. This is your answer. Letter D. So you have v plus 4u. take v plus 4 times this. You add the x components of the vectors, the y components of the vectors, and this is what you get. Number 6. Very similar to number 5. Now you only have A, B, and C. What is slightly different too, these are also vectors, but they're given in different form, and this is what we call that unit vector form. And I can rewrite any unit vector form in component form, and this is what I get. You should be able to follow how we go from here to here. This is the x value of the component form. This is the y value of the component form. That's why you have 2, -1. And you should be able to follow v. So now I do u plus v, very similar to number 5. This is what you get. This is component form. I'm going to express my answer in unit vector form because the problem started with unit vector form. So it's just I. B. You have to distribute here. Combine the x values of the vectors, combine the y values of the vectors. And this is what you get once you express as unit vector form. Last one. I'm sure you can follow. And this is what you get as your answer. Next slide. This one's a little bit different. I'll give you a formula. It says find the unit vector in the direction of the given vector. So this is the formula that you need to use to generate a unit vector. And basically it says that you take the vector, whatever it is, you divide it by the magnitude of the vector. So that's why I'm going to rewrite unit vector form into component form. And then I compute the unit vector by using the formula. So I take the vector w, it's in my numerator, find the magnitude of w, and this is what I get. Simplify this further, get the following. I rewrite it as unit vector form. Then I'm going to rationalize here, make the radical denominator disappear, and this is basically the answer. If I want to express this in vector form, this will be the answer. And you should be able to follow this very easily as well. Number 8 says find the magnitude and direction of the vector v. The magnitude is easy. Apply the formula you saw earlier, and you get 65. Now, this is the magnitude. Now let's find the direction angle. So what we're going to do is we're going to graph this vector, and this is what I get. I'm going to apply a little bit of trigonometry here to find that direction angle. So first, this is the angle that I need, this theta. Now, I'm going to use my reference angles to find theta prime. Theta prime is going to be 7 over 4. Theta prime is tangent inverse of 7 over 4. And you should be able to see the right triangle here. You did this earlier, chapter 4. This is your right triangle. Excuse me. This is your 4, this is your 7, and then this is your theta prime, this is your reference angle here. So opposite over adjacent, it's right here. Since you're looking for the angle, you want to use the inverse functions, and this is what you get. And at this point, you need to understand that this is only theta prime. How do I find the theta? I do the following, and this is the direction angle of this vector, and the magnitude is radical 65. So the distance from here to here is 65. The angle 240.3. Next. Says find the component form of the sum of u and w with the direction angles u sub w and u sub theta sub u and theta sub w. And this is the information. They give you the magnitude of vector u is 2, the theta angle is 30 for u, and magnitude for w is 3, and theta for w is 90. This is the formula we're going to be using. Whenever they give you the magnitude and the angles, and you want to write component form, this is the formula that you use. So here we go. Apply the formula to find u. Substitute the magnitude, the angle. Simplify the trig ratios here. This is what I get. I'm going to distribute the magnitude, or the 2, and I rewrite this. Once I multiply, I rewrite this in component form, and this is just the first part. I still need to find the sum, but I'll do that in just a little bit. I basically do the same thing for w. Apply the formula, apply the magnitude, the theta, simplify, rewrite this. Once I distribute and rewrite it in component form, this is what I get. So at this point, all I need to do is find the sum of u and w, and I apply what I learned earlier slide. So I'm going to basically add this two vectors. So I add the x components of the vectors and I get radical 3. I add the y components of the vectors and I get 4. And this is the answer to number 9. Let's move on to number 10. And this will be the last problem of this video. Very similar to number 9. Same formula. Magnitude for u is 7. The angle is 45. For w is 5. And for the angle is 330. So I go ahead and compute u. Substitute the information. This is what I get. I rewrite this in component form. I get the following. Now I find w, vector w, substitute the given information, simplify using the trig ratios, rewrite this in component form, and then at this point I need to find the sum of u and w. So once I add the x components of the vectors and the y components of the vector, this is your final answer. And this concludes the end of this video.